dummy variable, and interaction variable or interaction term. Yeah? And it will be quite an interesting class if you listen to me carefully. It's a really useful concept that we're going to talk about today. So far, when we learned the regression, yeah, all the independent variables were quantitative variables. Okay? Quantitative variable or numerical variable. Okay? Something that you could measure in units like length or weight or amount of money, something like that, right? But sometimes we need to include qualitative variables okay, as an explanatory variable in our regression. Okay? Something like gender. I think I mentioned it before. As a labor economist, I usually deal with equation, earnings equation. Okay? So dependent variable typically is somebody's wage earning, right? And on the right-hand side, I consider many independent variables like years of schooling, experience, the person's occupation, and so on. Okay? And gender is also an important variable in the earnings equation. Okay? Because, well, ideally it shouldn't make any difference whether a person is male or female. Shouldn't make any difference in their earning as long as they have same level of schooling or experience or same productivity, right? But in reality, unfortunately, gender makes difference. Okay? So and typically we include that as one of the explanatory variables. Occupation is another qualitative variable. Somebody's occupation, right? The manufacturing occupation or say machine operator or teacher or doctor. Yeah? Those occupations can make significant difference in earning. Okay? So how do we do that? How do we include this qualitative information as an independent variable in our regression? Okay? Well, we use dummy variable. Okay? So dummy variable simply means a fake variable. It's not really a real variable, okay? But we make it up, right? Make up a fake variable. Okay? So here in our example, let's say we're talking about pie sales as the dependent variable. We used this example before, right? And we use x1 price as the first independent variable. Well, price is a quantitative variable. Right? But suppose we want to include the holiday variable. Okay? In other words, well, if you remember this example, I believe the dependent variable was weekly sales of the pie, right? How many units of pie were sold in each week, excuse me. And we use the price as the independent variable. Okay? But this owner of the store is asking the question, if we have any holiday, right, during the week, does it make any difference in pie sale? Okay? In order to accommodate that kind of question, we can set up a dummy variable. We can set x2 equals 1 if there was a holiday during the week. Okay? 0 if not. Right? We can set it up that way. Okay? So, in your data, you have y, which is sales, and the price, and you have weekly sales. Let's say you have collected the information on, say, 15 weeks. Okay? Then you're going to have 15 observations of Y, okay? And also, what prices you charged in each week, right? And then you will create a new variable, say holiday, okay? Okay? And if there was any holiday during the first week in this data, let's say that was the first week of September in Korea. Well, first week of September, was there holiday? What was I guess October, right? I forgot. First week of October includes a holiday, right? Gacheonjo, right? Okay. Then you would say 1. Okay. The second week of October also includes holiday, right? Many holidays in October, right? Hangul날, right? Okay. And let's say third week of October did not, was it Chuseok? Third week. Oh, we had a lot of holidays, right? Oh, whatever. Let's see. And so on, right? So you artificially create this variable. It's not a real variable, okay? But it's a dummy variable, and you assign either 1 or 0, okay? All right, how does that work? Okay. So if you have this equation, right, say B0, once you estimate the equation, right, y hat becomes B0 plus B1 x1 plus B2 times 1 for holiday, if that week included a holiday, right? Otherwise, you're going to include the 0, substitute 0 here, right? So that term entire B2 disappears. Okay? So what difference does that make? Well, the difference will show up as an intercept here, right? So in the first case, during the week where there was a holiday, right, the intercept will be B0 plus B2. Right? But in the second case, where there was no holiday during the week, this entire term, B2 term, disappears, right? So the intercept will be simply B0, right? Other things, in other words, this slope, B1 will be the same, B1 x1 will be the same, right? So we have this downward sloping. Why is it downward sloping? You know why? Because it's price, right? If you charge higher price, sales is expected to go down, right? So we have two parallel lines here, right? But if there was no holiday, it starts from B0 intercept. If there is a holiday, it starts from B0 plus B2, right? So what's the difference between this intercept and this intercept? What's the difference between this intercept and this intercept? One? B2, right? This difference is simply B2, right? Right? This is B0 and this is B0 plus B2, right? All right. So that's the difference that holiday makes. In other words, holding other things constant, right? Holding other things constant. If a week includes a holiday, then sales is expected to increase by what? B2 amount, right? Get it? So by including the interaction term, dummy variable, right? By creating the dummy variable as 1, 0, right? And including in the equation, you can figure out the effect of that particular variable, in this case, holiday, right? Let's say I estimated somebody's wage, right? and I come up with, say, 2.69 plus 1.5 schooling plus, let's say, 2.1 experience and plus 0.85 gender. Okay? Then can someone explain, interpret this result? Wage is measured in dollars, let's say, right? Dollar per hour. Explain how the gender is created. 1 if male, let's say. 0, well, usually say otherwise, okay? But let's say in this case, yeah, otherwise. Well, traditionally we have only 2 categories, male or female, right? So let's say male, 0 otherwise. Oh, so let's make it clear, I guess. Female. All right. Right. And did you start with? Right. Good. Yeah, holding other things constant, right? What that means is, well, for every holding other things constant, for every additional year of schooling, you can expect someone's wage to increase by $1.50, $1.50, right? And holding other things constant, in this case, holding the schooling and gender constant, right? If someone's experience, labor market experience, increased by 1 year, right? You can expect that wages to increase by $2.10 per hour, right? And so on, right? And then here, what that means, because we have created gender variable this way, right? Compared to female, if this person was female, right, then this would be 0, which means this entire term will disappear, right? So female earnings equation is from here to here. That's it. Okay? Female. But if that person was a male, then this value would be 1, right? So you are adding 85 cents, right, to female earning. Okay? So we are talking about the difference. We have, well, since we have multiple terms, we cannot actually draw the graph or the line, okay? But think about the intercept. For female earnings equation, intercept is $2.69. Okay? So, again, we don't really literally interpret the intercept, right? But mathematically, intercept means if this is 0, if this is 0, right? Everything is 0, right? Then the person's wage would be $2.69 per hour, right? But if that person was a male, then it's going to be $2.69 plus 85 cents. So holding other things constant. Okay? If you have two people with the same amount of schooling and same amount of experience, just because that person was a male, right? The person's earning would be higher by 85 cents, right? That's the meaning of this estimate, coefficient estimate. Okay? Clear? Okay. So that's how the dummy variable works, by just creating a variable using 1 or 0. By assigning 1 or 0, right? We can figure out the effect of that variable. So in this case, effect of gender is exactly 85 cents. It makes the difference, okay, of 85 cents depending on the gender. Okay? All right. So here, this is just an explanation of the previous example. Yeah. The question is, some qualitative variables have more than 2 levels. So far, we've discussed the holiday dummy variable and gender dummy variable, right? So either holiday or not holiday, either male or female, right? Just 2 levels, right? But actually, many qualitative variables have more than 2 levels, like occupation here. How many different occupations are there? Right? If you use the official documentation, right, they have 3 level, actually starting from 1-digit level occupation category, 3-digit level occupation category, 5 different. So let's say 1-digit level occupation category goes like FFF, standing for farming, forestry, fishery. Farming, fishery, forestry, right? So, the farmers, fishermen, and, the lumberjacks working in forestry, right? That's occupation category 1. Okay? 2, something like machine operator, right? In a factory, right? Something like that. 3, maybe go service worker. Okay? So the 1-digit categorization, right? Divide or assign all the occupations into from 1 through 9. Or, yeah, you can use either 1 through 9 or 0 through 9. Okay? Right. But then, if you go to 3-digit level categorization, it becomes a lot more detailed. Okay? So out of farming, forestry, and fishery, okay, 111 is, say, peanut farmer, right? Peanut farmer. 112 is wheat farmer, something like that. Okay, 3-digit level. Okay, so it will be a lot longer, many different categories. Okay? Well, in my case, in my research, I seldom use more than one-digit category because it's going to be too many, right? So I have to. Let's say I want to use 1-digit classification for occupation, right? And that means I have to handle at least about 9 different levels, right? So even in one variable for occupation, right? I have 9 different levels. How am I going to handle it? Okay? Well, so here let's start with a very simple case. Suppose we have one independent variable, one qualitative independent variable, which has 3 levels. Now, we've been dealing with the 2-level case. Okay? So let's just increase by 1. So 3 level. Okay? So this is a house price. Your dependent variable is house price. Okay? And you have first the independent variable as the square feet, which is size of the house, okay? Which is a quantitative variable. Okay? But then you also want to include location. I think I gave you the joke, right? Location, right? Right? The most important determinant of house value is location, right? So let's say urban, suburban, and rural, 3 different categories. Okay? Again, I mean, as far as location goes, you can have many different classifications. Okay? But maybe you can, even within urban, is that inner city or slightly outside the inner city or something like that, right? It can make difference, right? But let's simplify the matter, right? And say we have 3 levels, okay? How do we handle this? If you have 3 levels, you cannot do, if I ask this to students before teaching this dummy variable class, right? They would say, okay, why don't we create 3 levels. So X2 is 1 if urban, 2 is suburban, and 3 or 0, 1, 2. Anyway, something like that, right? That's not going to work that way, because the way it should work is it should make difference in the amount of intercept. Okay? So we need 1 or 0. Okay? All right. So what do we do? How do we do that? If you have 3 levels, then you have to create 2 separate dummy variables. Okay? So here we have dependent variable and the square feet as the first independent variable. Now, in order to handle the location, 3 levels of location, we create the first variable. You can say X2 or you can say urban, right? And that means you are assigned 1 if that particular house is within urban area, 0 otherwise. Okay? You create another dummy variable, this time for suburban, okay? And you assign 1 if that particular house is from suburban, right? 0 otherwise. Okay? So here we have price, size, and urban, suburban. Okay? And suppose you have collected information on, say, 50 different houses, right? 1, 2, 3, down to 50, right? And you have all this price information for each house, size information for each house, right? And then the location of the first house, suppose it was within the urban area, right? Then you're going to assign 1. Let's say and of course this will be 0 because it's not suburban, right? The second house, so suppose it was in the suburban area, right? Then it's going to be 1, 0, right? What about the houses in the rural area? Suppose the third house is located in rural area. Yeah? 0, 0. 0, 0. Right? You don't create another dummy variable for rural, right? You don't need to do that, right? Because if you look at it, right? When we had 2 levels, we created 1 dummy variable. That was sufficient, right? By assigning 1 or 0, right? So if you have 3 levels, right? By creating 2 dummy variables, okay, you can do either 1 or 0. Okay? So yes, you assign whatever that way, and you create these dummy variables, and then you just run the regression. Okay? So the result will look like this, right? So after running the regression, suppose you got this estimated equation. Okay? Y hat is 20.43 and so on, right? So let's try to interpret the meaning, right? For a house located in rural area, right? X2 will be 0. X3 will also be 0, right? So for the houses in rural area, the equation becomes very simple. This is it, right? 20.43 plus 0.045 times x1, which is the size, okay? For houses located in the urban area, x2 will be 1, x3 will be 0. So this term disappears, right? So the estimated equation becomes like that, right? For houses in suburban area, x2 will be 0, right? So equation ends up being like this, right? So if you look at these three equations, these terms, the 0.045 times x1, in other words, the effect of the size is the same. It remains constant. I mean, it's all the way the same, right? The only difference is what? Where is the difference? Intercept, right? Because the intercept for the first case is 20.43. Intercept for the second case will be 20.43 plus 23.53, right? Okay. So we have three separate, say, X1 house price, okay? Three separate cases. Okay? So we have, which one is which? Looks like this is the rural location without any, and that's 20.43, the intercept, right? For urban location, that's what? 20.43 plus 23.53, okay? And for the suburban location, right, it's 20.43 plus 18.84, okay? Oh, sorry. That doesn't work that way, right? What am I doing here? I was thinking something else, right? 20.43 plus 18.84. Okay. All right? So we have three parallel lines. The only difference is the intercept. Okay? So you can easily see the effect of location variable. If a house is in urban location, holding other things constant, right? Right? The compared to the rural location, the price will be higher by, I believe the unit was $1,000, right? Here, $23,530. So that's a $23,530 higher, right? Than the same house, same size house in rural location, right? If the house is located in suburban area, then you can expect the house price to be higher by $18,840, higher than the same size house in the rural location. Okay? So, in other words, we have created urban variable, suburban variable, but we have omitted rural variable, right? Out of three levels, we have omitted one level, right? So if you think about it, if you have 5 levels in any dummy variable, in any qualitative variable, you need to compare 5 different levels. How many dummy variables do you need to create? 4. If you have, in the United States, there are 50 states, right? And so many times we compare different states, right? So in order to compare 50 states, how many dummy variables do you need to create? 49 separate dummy variables. So you need to omit one level. Out of all the levels, you always omit one level, right? And that omitted level becomes base for comparison. Remember that, right? Omitted level becomes the base for comparison. everything is compared to that omitted level, right? So in the gender case, omitted level was female, right? So compared to female, male wage was higher by 85 cents in that example, right? In this case, omitted level was rural, right? So compared to the rural house, right? The house in the urban area was higher by 23.53. Compared to the rural house in a suburban area is higher by 18.84. Okay? Everything is compared to the omitted level. Yeah? Well, so what about the difference between urban and suburban? We can easily see the difference between the urban and rural, and suburban and rural, right? But what about difference between urban and suburban? Can we figure it out? So by looking at this graph, you can easily figure out, okay, if the difference between the rural and the urban is 23.53, that's 23.53, right? So the difference between urban and suburban is simply this, right? That's 23.53 minus 18.84, right? So by omitting one level, right, you can figure out the difference between any combination, any pair of the levels, right? For example, let's say in my wage earnings equation, instead of comparing the 50 states, I mean, it's going to be too many. I mean, I don't want to include the 49 state dummy variables, okay? So what I usually do is I create region variable, okay? Because region makes difference in the United States. In other words, where you work, right? So I usually create 4 regions, northwest, northeast, southeast, southwest, right? And so that means how many dummy variables do I need to create for region? 3. If you have 4 levels, right, you need to omit 1 level, create 3 dummy variables, okay? So wage goes blah, 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 okay? Goes a 1.15 northeast plus 0.62 southeast, okay? Minus 2, let's say 1.25 southwest. Suppose I got that estimate, right? Which means northwest is the omitted level, okay? So all these estimates tell me what? The difference between northeast and what? Okay. Can someone interpret this? $1.15. Holding other things constant. Yes, right? So holding other things, all other variables constant, if you work in the northeast area, right, you can expect your wages to increase or be higher by $1.15 compared to the northwest, right? The omitted level, right? The same thing here, right? If you work in southeast area, right, the wage will be on average, wage will be higher compared to the northwest by 62 cents, right? And what about this? Negative 1.25. This is $1.20, right? So wages measured in dollars. So what that means is if you work in southwest area, southwest region, right, the wage is expected to be lower by $1.25 compared to the Northwest region, right? Remember, the omitted level is always the base for comparison, okay? Well, so if you want to compare, let's say, Southwest and Southeast, what are you going to do? You don't want to work in cold area, right? So you always want to be in the south, right? But you're trying to decide whether you should work in southeast or southwest. What's the difference? Can you find that out? Okay, here's the base for comparison, which is northwest. Okay? Northeast is higher by $1.15. Northeast, that's $1.15, right? Southeast higher by 62 cents. And Southwest is actually below here. It's lower by 1.25, right? And I'm asking you the difference between the Southwest and Southeast.
Okay.
Right? That makes sense, right? Okay?
1.85.
Right. You have,
97.
right. You have to actually add. Well, actually, you did the right thing. You have to subtract it. 0.62 minus 1.25. Right? That's what you should do. Okay? All right. Okay, so make sure you are able to interpret all the coefficient estimates for dummy variables correctly, right? Make sure you understand why we need to omit one level, right? And why the dummy variable can only have either 1 or 0, right? Okay? Any question about the dummy variable? Okay, good. Yeah, so in your project, you will have to create some dummy variable, and I'm sure you will enjoy using this concept of dummy variable. Right? It's quite, useful concept. Okay? The other topic for today is interaction. Okay? Interaction term. Okay? So the story here is when we have multiple independent variables. Okay? Sometimes we can suspect some interaction between 2 or even 3 among the independent variables. Okay? So here, in my typical example, right, we have, say, beta naught plus beta 1 schooling, beta 2 experience, plus beta 3, say, gender. Suppose I have 3 independent variables. Okay? And I suppose I got some estimate. So B0 plus B1. Yeah, I got, let's say, 1.5 schooling plus 2.1 experience plus 0.85 gender. Okay? We all know what these mean, right? We already interpreted all those coefficients. Okay? But you may ask the question, is that really true? I mean, depending on, say, gender, right? Whether you are male or female, will this number remain constant? Is that really true for both men and women, right? For every additional schooling, wage increases by $1.50, and for every additional year of experience, right, that person's wage will increase by $2.10 for both male and female? Well, in reality, that is not true. See, gender makes difference in these coefficients, the amount of, in other words, effect of experience. Effect of experience on wage is influenced by another variable. Effect of schooling on wage is also influenced by another variable, could be gender or experience. Effect of experience, it's called what we call wage experience profile. Okay? If you put experience here and wage here, normally, as you acquire more and more experience, you can expect your wage to increase. Okay? But in reality, it's not really a straight line. In reality, it's actually something like that, right? In other words, when you're young, when you graduate college and start gaining labor market experience, your wage goes up fast. Okay? But as you age, become 40 years, 45, 50, right? There will be a peak. Okay? And after that, actually your wage can go down, right? Something like that, right? That's our next topic in chapter 15, right? This nonlinear case. Okay? But let's say we have linear straight line profile between wage and experience. Okay? But we actually see the difference in this relationship between experience and wage depending on your schooling level. If you have only 12 years of schooling, which is high school graduate, right, then you may have this kind of wage experience profile. If you are a college graduate, typically it's steeper. Okay? In other words, for same 1 year additional year of experience, right, your wage increase faster if you're a college graduate compared to the high school graduate, right? So the story is the effect of experience on wage is influenced by schooling, right? That's what we mean by interaction. There is an interaction between schooling and experience. Do you understand the concept? Okay. So how do we include this consideration in our estimation, right? Well, we include an interaction term. Yeah? Interaction term is simply the multiplication or product between the two independent variables. Okay? So if you suspect any interaction between x1 and x2, right, you will create an interaction term by multiplying these two variables and include it in the regression equation. Okay? All right? So once you create the interaction term, the rest is the same. You just run the regression. How does it handle? How does it work? So here, the example was, let's say, what was y and x1, x2? Okay, forget about it. That's fine. Okay. Let's say just we suspect interaction between x1 and x2, right? So we ran the regression with the interaction term, okay, and came up with this estimate, right? Y hat is, this equation, right? So what does that mean? If x2 was 1, just like, well, let's say x2 was gender, right? So 1 means male, 0 means female, right? Then if x2 was 1, then we have this equation 1 plus 2x1 plus 3 plus 4x1, which is 4 plus 6x1, right? But if x2 happens to be 0, then we have only 1 plus 2x1, right? So we have two separate profile or two separate relationship between x1 and y. Okay? So that handles the interaction effect between x1 and x2, right? In general, though, well, this was the case, special case of x2 being a dummy variable, either 1 or 0, right? But what about the more normal case of x2 being a quantitative variable, like in my case, right? Suppose x1 is experience, x2 is schooling, okay? So we want to see the effect of experience on wage, but we suspect the interaction effect between schooling and experience. Okay? All right. So how it works is this. Okay? So we have model of, say, beta 1, beta 0 plus beta 1 s plus beta 2 experience. Right. And suppose you suspect interaction between S, schooling, and experience. Okay? Then you're going to include interaction term, S times experience. Okay? Then, I guess in this class we are not supposed to use calculus. Okay? And we're not going to use really complicated calculus, but I have to, well, introduce very basic concept of calculus, right? Calculus is a very simple idea. If y is a plus bx, right? The dy dx is what? B, right? Just simply the coefficient b, right? Because what we are trying to find out is if x increases by 1 unit, what happens to y? That's what dy dx means, right? Oh, I'm just trying to simplify, right? So, that's the coefficient b, right? If y happens to be a plus b x plus c x squared, then when you take the derivative, dy dx, it's going to be what? 2 times cx, something like that, right? How many of you have never learned this simple calculus? Never learned. Okay, everybody had some basic calculus here, differentiation. Okay, good. So we're trying to find out the effect of x on y, right? So here, since we have more than one independent variable, we use partial differentiation. Instead of dy dx, we use this partial sign, okay? I guess this delta, right? Delta stands for d, right? This, Greek, delta is d in Greek letter, okay? All right? And so what we do is a partial of w, wage, with respect to experience, right? So we want to know the effect of experience on wage. What happens if the experience changes, right? Well, that's going to be, So suppose we estimated Okay, you know the difference between beta and B, right? This is the model, and this is the population parameter. This is the sample statistic, right? Estimated value, right? So if you take the derivative, what you get is B2 and what do you get? B2 what? Plus B3S, right? Right? Okay? So that's how the interaction term works, right? So when you include this interaction term and take the derivative, right, to find the effect of experience on your dependent variable, you're going to get this, which is the pure effect of experience on wage, plus effect of this S on the relationship between experience and wage. Okay? All right? So we're going to have, well, let's say it came out, it was, say, 1.5, and suppose this B3, I'm sorry, I think it was 2.1, okay? And B3 came out to be 0.75. Okay? Then we have this experience and wage. Okay? So depending on the level of schooling, right, you're going to have different effect, different slope. You remember this is the slope, right? Okay? So let's say, to make it simple, let's say S is 2 versus 4, right? So you have one person with only 2 years of schooling, another person with 4 years of schooling, right? Then for 2 years of schooling, that will be 2.1 plus what, 1.5, 0.75 times 2, okay? Which is what, 3.6, right? For 4 years of schooling, it's going to be 2.1 plus 3.0, right? Which is what, 5.1, right? So what that means is we have two separate slope. Okay? It's a slope of 3.6 versus 5.1, right? This is for the schooling level of 2 years. This is for schooling level of 4 years. Okay? So what's the story? Can someone interpret this 3.6 and 5.1? Holding other things constant, right? Anybody on this side? Tajun, want to try? Holding other things constant? No, we are trying to find the effect of experience on wage, right? This is supposed to give us the relationship between experience and wage, right? So for every additional year of experience, what? In this case, go ahead. Yeah.
The person who has schooling for 2 years,
Mm-hmm.
every year of experience,
Mm-hmm.
his wage becomes $3.6
Mm-hmm.
every year. And someone who did 4 years of schooling,
Uh-huh.
he becomes $5.1 higher every year.
Yeah, that's right, right? So holding other things constant, the person's gender or occupation or region, all those other variables constant, right? If the person has only 2 years of schooling, for each additional year of experience, right, we can expect the person's wage to increase by $3.60, right? But if the other person, the same gender, same region, same occupation or whatever, right? But the only difference is this second person has 2 more years of schooling, 4 years of schooling, right? Then, just because of that, right, the effect of experience, I mean, 1 additional year of experience will increase the wage by $5.10, right? So we're talking about the interaction effect. Effect of experience on wage is influenced by another variable, schooling, right? And that can be figured out, that can be found out by including interaction term, okay? And this one, B3, gives that effect of interaction between schooling and experience. Okay? Make sense? All right? All right. So we're about time. We're out of time, but why don't we try this? Yeah, let me give you second homework. Did I give one homework so far? Yeah, okay. Let me give you a second homework.